Hi everyone, and welcome to another episode of Mr. Carlson's Lab. On the bench today is an extremely big Westinghouse tabletop radio. This thing would take up an entire table, and it's incredibly heavy as well. The story goes like this. The owner restored this thing quite some time ago and did a wonderful job on the case. It really looks quite incredible. And he also tried to restore it electrically, and that's when it ended. So it hasn't worked since that point. So our job today is to go through this thing, troubleshoot it, and find out where he went wrong and correct the issues. So let's get started. Here's a really unique feature of this Westinghouse radio. It has a drawer in the bottom. So you can open up the drawer, and in the drawer is a booklet, a little pocket on it, so you could put your radio license in there because yes, way back when, you needed a license to receive. So if you owned a radio, you had to have a license. If you pull the drawer out to its extent and tip the drawer forward, there's lights inside the drawer. And there's a little switch in there that turns it on. So you can see this if you're listening to some late night DX. So I'll just move this over here. It has a Westinghouse International time map here that you can rotate. And then if you open the booklet here, has all sorts of different radio calls from way back when. Really neat just to have this. This is still intact and still in the drawer. Really, really neat. So you lift the drawer up and it shuts the lights off and ease the drawer back in. And that's about as far as I want to go powering this radio up right now because it's just making a humming noise, and I've noticed some very strange things going on with this radio, and I'll explain here. So what I'm going to do is I'll turn this thing around, we'll take a look at the backside, we'll remove it from the cabinet and start troubleshooting. Here's a look in the backside of this radio receiver, and as you can see, it's really nicely laid out. Lots of space between the vacuum tubes, a bunch of coils over here and some transformers here and here. This is the main power transformer here, and as you can see, it has a really large core. And the reason that this transformer has such a large core is because it's designed to operate on 25 or 60 cycles. So the lower in frequency that you go, you need more core, and that's the reason the core is so incredibly big. This is the reason in switch mode power supplies you can get such a high amount of current out of such a small transformer. The core size in switch mode power supplies is a lot smaller because it's operating at a very high frequency. So higher frequency, less core, lower frequency, more core. That's why in high fidelity audio amplifiers with really good output transformers, the cores are really big. You can see here somebody's taken the time to rewire the dial lamps. So this is a reproduction cloth cord here. That looks really nice. We'll have to check that out. This is the speaker up here. I don't see any tears in the paper, which is kind of nice. This is an electromagnetic speaker. So back in the day, they didn't use permanent magnets. This here is a coil. And when the vacuum tubes in the radio start to draw a current through this coil, it magnetizes the speaker. So this also serves as a filter for the power supply. It helps reduce hum. And in some cases, there's even a humbucking coil in there as well. This is the audio output transformer right here. So what this does is this transforms the higher impedance from the vacuum tube down to the lower impedance of the speaker. So that's what it's doing. This is the audio output tube right here. And that tube there gets extremely hot in any service. This is a 6F6 tube. They get, very, very hot. So you definitely never want to touch something like this when it's in service. When I had this thing on, demonstrating the drawer in the front, the lights, I could actually smell this tube. I guess the dust on the tube from sitting for so long. So it was getting very, very hot. Right here is the two power leads that run to the lamps in the drawer. Antenna and ground connection. This says for lamp only right here. So you could plug in an external desk lamp. So say you're listening to some late night DX or late night distance stations if you like. You can have a book or something there. You can write down or log what you're listening to. So they definitely didn't want you to be drawing any current from this outlet because it's just for a lamp. So these look very, very old. Hopefully those filter capacitors have been replaced on the underside of the chassis. It did have a bit of hum, so I don't know, maybe these are still in circuit. I hope not. That would be not a good thing. They definitely don't look like they're in very good condition either. So in order to get this chassis out of here, I have to get under here. You can see these little areas here with a wrench, 7/16 it looks to be, or something like that. The head on the bolt looks to be about that. So in order to do that, this is a really heavy chassis because of this transformer here. So what I'll do is I'll slide this over to the edge of the desk. So this little area is over the edge, and I'll just remove these screws and slide the chassis out, get that out of the way. And then we'll remove the speaker together, and we'll discover whether the paper is good and what's on the other side of that speaker. Okay, let's remove some of these things here. As you can see, they weren't kidding when they put this thing together. Nothing like using parts to build a car in your radio. Okay. I've loosened off these two screws here, and I've removed these two wires. So this wire here was like this, and this one was like this. So that gets those out of the way, and I've removed the little clip up here that holds this wire. It's just basically a wire restraint. And then I can unplug this from the speaker, just that easy. There is the little plug that goes into the speaker. Now this should just slide out. All the knobs are removed on the front side of the radio as well. There it is. And it is not light. I can tell you that. Okay. I'll just move this out of the way, put this on my nice soft chair back here. The wires that run up to the lamp, not in bad shape. You can tell the chassis has been taken in and out multiple times. I'll just zoom on in to that speaker, and we'll work on taking that out. This over here. There we go. Get that into focus. There we are. Now, hopefully the speaker is going to be okay. So this is a 1132 right here. And they're not very tight. So this on here is pretty loose. Do this, holding this into place. They are loose, but they're not spinning on the other side. Okay. I always want to be very careful when you pull this away from the studs, because if you don't, you can pierce the speaker. There we go. And it definitely looks like it's got lots of crud in there. I'll just buzz the focus up on that. Look at all that crud. Cobwebs and stuff down here. We'll take a closer look at the speaker here in just a moment. Here's a closer look at the chassis and the speaker. As you can see, I already ran my finger in some of the dust here. You can see that? So there's a really fine dust on there. The actual speaker itself is not binding, so that's a really good sign. And there's just lots of crud in the rim here and cobwebs and things like that. So I'll take a very fine brush. I'm not talking a toothbrush or anything like that. I'm talking something very, very fine. And I'm going to get in here and just very carefully remove the dust and the crud. Now when I'm doing that, I'm going to be doing this with the speaker face down so that it all doesn't roll right into the center here and cause this to bind up. Now whenever you remove a speaker like this from any type of an old radio like this thing here has got magical powers. What this will do is this will attract every screwdriver on your bench. They'll magically come flying across the bench so that they can pierce the paper in here. Any of you out there that have been working on old radios or been working around speakers for years will know exactly what I'm talking about. So I don't know what it is. It's just screwdrivers love to find the paper on these beautiful old speakers and pierce them. So what I'm going to do is get this thing completely out of the way until I'm ready to power this up. I can't power the radio up without this attached because the high voltage from the radio goes through this. So this will just get removed. and put completely out of the way. So nothing or no damage happens to it. Chassis itself, again, looks like it's in really nice condition. What I'll do is I'll just tip this up here. Now when you see holes, there's actually a whole bunch of writing here too. See that writing? June 6th, 1959. Somebody's put a repair or something on here. Kind of neat to know that somebody wrote that in 1959. So you can see on the bottom here, there's a bunch of holes in the bottom panel, and that's not for breathing or anything like that. These are alignment points. Now what happens is when you do an alignment on a radio receiver like this, the bottom panel has to be on when you do the alignment. Reason being is the coils inside will capacitively couple to this bottom panel. So if you align it without the bottom panel, it'll be fine. But the moment that you put the bottom panel on, it will drag everything right off. So it'll drag your alignment right out. So that's something to always remember. You can actually see some of the alignment points right in there. There's some of the alignment screws right there. See that right inside there. They look like capacitors through the bottom panel. And I can see the ones way up inside the chassis up in here as well. See if I can, yeah, you can see them way up in there. So that's what those are for. And these here will be for this set of transformers over here. There is no alignment point through these top holes here. That's the way these older receivers worked. Let's see this and move this around a little bit. Some more writing. The dial itself is in really nice condition. So little shields here, all the controls. Oh, I do see a capacitor has been replaced. That is a good sign. So that is good. Here we go. A reduction drive on there. So this allows you to fine tune. And then this is a coarse tune. And then there's a little reduction there. So these will almost likely have to be cleaned. On and off. And the one that you can't move is most likely the band switch. Oh, that would definitely be the band switch. So there we go. We'll figure out what all the controls do later on. It's bound to be volume and tone and whatever. There's nothing written on the wooden case there. Let's take a look at the other side of the chassis here before we remove the bottom panel. Look at the size of that transformer. It's just absolutely huge. Look at the size of that thing. So, nice 25 cycle transformer there. So, let's see. All this wiring up here has been replaced. That's that replacement cloth wiring. Okay, let's take a look on the bottom side here. Alright, so as he kind of wants to tip, we'll just put that under the transformer, like so. Okay, so we'll remove some of the screws here. There are screws missing in here, so yeah, definitely has been opened before, and we definitely know that because we've seen here 1959. And then, of course, the previous person that was in here that tried to get it working, and that didn't happen. So let's see back here. Okay. Are you ready? Here we go. Let's see what's inside. Do you think it's a mess? What do you think? Here we go. That's actually not bad. Not bad at all. These look a lot like the capacitors that I use. The ones that I use are Illinois. ETR, MET. So, if I just get out of shot here for a second, I can grab some of the ones that I use. Right out of my own bin here. These are the ones that I use. Ones that I use are made by Illinois Cap. These are really good. It's a little bit different. Color's a little bit, seems a bit darker on these capacitors too. That's okay. replacement electrolytics down here. So what I'm going to do is I'll reposition the camera, get a little bit closer so we can get more of a square on view of the chassis, and we'll take a look at what's going on, a little closer look. The old electrolytic capacitors have been completely removed from circuit, and new ones have been installed by the previous person that was in here, which is nice to see. A lot of times when I open up radios like this and somebody's worked on them, what they've done is they've taken new capacitors and they paralleled them across the old ones. And you absolutely cannot do that. Reason being is even though the old capacitor measures open or very low capacitance, they just randomly close. So the radio will be on and just one day it'll randomly short. And if it shorts, what it does is it basically shorts the power supply and it causes damage to the radio. The last thing you want to do is open that field coil on the speaker. So that would be a definite issue. Then the speaker is pretty much toast at that point. You'd have to either rewind the field coil or find another replacement speaker. So it's nice that these are out of circuit. I can see that there's a mixture of old and new parts in here. So this is a newer Allen Bradley style resistor right here with the squared off ends. And then we have the old bed style resistors. So bed like the bed you sleep in. That stands for body end dot, and that's the way you read the values on these resistors. I've explained that many times in my other videos. Again, a newer Allen Bradley style resistor tied into circuit here. So there are a bunch of components here that have been replaced and updated, as we can see all over the place here. You can see that wires have been clipped and these new I guess you could call it reproduction cloth type of wire has been installed, and then there's some white heat shrink on it here, and some more heat shrink here and here. Whenever you see black tape like this fibrous old black tape, that is usually factory. So what they do in order to save a standoff or a terminal tie strip is they'll join some wires and they'll just put some tape on them. A lot of the time you see this in line with the B+ or the line cord, things like that. This is, of course, is new black tape right here. It's holding in the new capacitors to this little area on the side. Lots of mica capacitors in here, which will most likely be okay. If you don't have to replace these mica capacitors, especially the one around the coil area, you definitely don't want to do that. If you can leave them alone, leave them alone. Reason being is many times these capacitors were hand-picked at the factory to make the dial track correctly. If you replace these capacitors with a capacitor of the same value that looks to be the same value, many times they're, could be out by 10, 20, 30 picofarad, and then trying to get the dial to track correctly on the front. So basically when I say the dial tracking, what I mean is that when you're listening to a frequency, you want the needle on the dial to point to that frequency. If the tracking is incorrectly set up, or if the tracking isn't right in the radio receiver, what'll happen is that you could have the dial pointing at, say, 900 AM, but it's listening to 1000, right? So that's the dial tracking. Remember, you have to make an oscillator in here track with an analog dial on the face. And when they designed these radios, of course, that took a lot of time to make that happen. So quite a bit of time in perfecting that. So again, if you can leave the micas alone, you definitely want to do that. And that's these domino style capacitors in here. Now, some radio manufacturers were kind of tricky. They hid paper capacitors inside these domino style cases. So that's another thing that you have to look out for. So all in all under here, it looks pretty good. The person that was in here that tied in all the new components. Again, here's this J-hooking kind of idea. I don't like the J-hook idea for tying in new components. What I do is I completely remove everything from the socket and I'll install brand new components right from the socket to the other point. But a lot of people, they'll clip the old parts out and leave a little bit of lead and then J-hook the new component in and tie it off. It's just all what you're into, basically, however you want to do your restore or your restoration. So what I'm going to do now is get that speaker back into the shot, into a safe area, and we'll turn this thing on here, and I'll rotate some knobs and dials on the face here and see if we can get any sound, and we'll see what's actually going on in this radio receiver, and then we'll start hunting for problems. I have the radio attached to my isolation transformer and current limited variac supply. And when I say current limited, I have a very light fuse in my variac. So if anything goes wrong, that little fuse will just go away. The radio itself is supposed to draw under 100 watts. I think it's in the 70 watt zone. So what I'll do is I'll turn this on and keep an eye on the watt meter. This will immediately go to 120 volts even though the variac is set lower. So I can run this up to 120. So usually these radios ran between 110 and 115. We'll leave it at 115. How does that sound? Here we go. Turn this on. And so far, no problems. It's a little over 50 watts right now. I'll zoom into that here in just a little bit. And that's not doing too bad. That's right about 70 some odd watts, right where it's supposed to be. So I'll just zoom into the meter up there for a moment. You can take a look. So you can see the first line is 50 watts, and it's right between 50 and 100 watts there. So it's about 75 watts, something like that, and that's absolutely fine. So what I'll do is I will rotate the band switch here and see what's happening. So here we go. Just use this knob here on the band switch. There's no sound, nothing is happening here. It's pretty quiet. See, rotating the band switch. The lights appear like they're trying to change. So I'll get you in on that up there. You can see that the lights there are trying to change with the band switch. Oh, and that position is definitely no good. Okay, so this one position right here, when I move this to here, bad things happen. I'll show you what I mean. So I'll take a look at the watt meter here again. So I'll move the band switch over to that position. Whoa, just under 150 watts. So something is shorting out in that band switch. Yeah, definitely. So that's not good. I'm definitely glad it wasn't on that when I was testing the dial lights. Obviously the dial lights wouldn't glow because it looks like it's... Yeah, all the heaters are dimming out. I can see that even in the rectifier tube, it's pulling the rectifier tube down. So something is wired wrong, I would imagine, in these... we take a look here. Something is probably wired wrong up here, I imagine that. The band switch is obviously switching the lights around. So probably something is going wrong here. So what I'm going to do is I'm going to go grab the schematic, and we'll take a quick look at the schematic and see what's going on. So there we go, 4 lights here. Lots of dust on that dial. Wow. Definitely wipe that all off. Okay, so immediately I see a discrepancy here already. Notice that there's 3 dial lights on the schematic, and there are 4 dial lights here. So that tells me that somebody's probably added a dial light at some point. So if I move this down here, see there's a dial light there. So this has got what looks to be a threaded base. Just remove that for now. And I'll remove this here. Yeah, and these are threaded. So I'm just going to get rid of these shields because that's going to make things easier for us to see. I'll just move this up here. And I'll take this one off here. Oh, that's strange. So, and this one here poked me. Okay. So that is a bayonet type. Sharp wires there. So that's telling me that we have 3 threaded bases and one that's basically you push it in and it locks. So what does that tell us? This one here is odd. Now, if we look at the schematic here, we can see that we have 2 leads basically running to the whole switching system. So one lead is going to run to the switch, and then the switch is going to switch between the 3 lights, obviously for the 3 bands. And then the other lead is just basically going to be like a common to all three lights. You can see 1, 2, and 3. They're just all bridged together, and then that one runs out this one wire. Now, there's a whole lot of wires here. And, one other thing that's very important to mention. If you look at the filament system here, there's a center tap on the filament system here. So we have each side that runs out to the heaters, and then this center tap runs to the chassis, and of course that helps reduce hum. Now, if we look here, we can see that each one of these is isolated from the chassis, although the threaded ones are. Yet, if we look at this one, these wires are soldered directly to the case here, and the case clips directly to the chassis, and if I touch the case to the chassis, there is some very strange wiring thing going on here. And that light is not very bright. It looks bright in the camera. And this one here is not bright, as you can see. But they should be way brighter than that. So, obviously, nothing is supposed to be going to the chassis. So if I click this now, this is off the chassis. So now if I move this over to that other position where it's shorted, there's nothing happening now. So you can see the short is definitely in the filament system. So I'm going to move here, right? I'll move the... So nothing's happening. So now what I'll do is I'll move this, I think, which position was it that it was shorting in? That one there. Yeah, so there you go. So take a look at this. Just move this over here. Take a look at this. So this is in the position where it's shorting. So there's a direct short in the filament system through this one. So this isn't supposed to be here. Now, oddly enough, they have 4 clips here. So there's a clip here, clip here, clip here, and clip here, but they only show 3 bulbs for this model. So what's happened is somebody has tried to add another bulb to make this light maybe just a little bit more evenly or something like that. If I look at the edge of the glass here, you can see that they've painted a red coating on this portion of the glass and a green coating here, and then down on the bottom you can kind of see it through the edge of the glass is a blue coating on here. So this light here is obviously to light this portion of the band, the red, right? Because there's a red filter here, and then there's a green filter on this portion of the glass, so that's obviously to light the green, and then the rest would be blue. That would just, be the way it goes. So what we really need to do now, first of all, is find out what is actually going on here. We need to locate 3 wires that switch with this switch down at the bottom, with this band switch. So we need to find the 3 wires that are coming out of here. So when I move this, one wire should have, 6 volts on it, 6.3 volts. And then when I move this, move that one around, the next one, should have 6.3, and it should go like that as I move this back and forth. And then, of course, that will be common to one wire. So one wire will stay with my voltmeter, and then it'll move between 3 other wires for the 3 other bands on this dial here. And this, of course, will just have to go because, this is, one of the connections is directly to the shell, and of course that shell is going right to the chassis. So that should be technically at half of the voltage. So what I'm going to go do is grab a voltmeter, and that should be around 3 point something volts between here and here right now. I'll be right back. Since a portion of the filament winding is shorting to the chassis is the center tap of the filament winding. So one end of the filament winding would be shorting to the center tap, which would mean that we would have half the filament voltage there. So it should be around 3 volts, maybe a little bit over 3 volts from this point to this point here if we do have a short. So what I'm going to do is clip my AC probe common onto the chassis, and what I'll do is I'll take the probe and I'll just touch it to this point here. So we'll take a look at the meter. Zoom on into the meter. So we're on the top scale, so that's 2 volts, 4, 6, 8, and 10 volts AC. So we should be roughly between the 2 and the 4 for 3 volts, which would be half the filament winding. So what I'll do is I'll touch this right here, and look at that. So half the filament winding is shorting to the chassis through this one lamp socket over here. I'll just disconnect this, set this down. So if we go here, we definitely know that this is taking half of that filament winding right to the chassis. Now, it's a really, really good thing that this was not left in that position for a very long time, or it would have probably burnt out the filament winding in this very nice transformer. So it's a good thing that that was found, and of course this right here is the problem. So the next thing to do is basically to find out where all the lamps are. We need to remap what's going on here, and then this needs to get rewired. Look at this. There's even a wire tied off here. So look at this. Move this around here. Look at this. Just tied right off. What's going on there? Where's this going? And it's going down into the bottom. So, well, we'll find out where all the leads are and wire the lights appropriately. I've removed all the lamp sockets, so I basically just cut the wires to all of these because it's going to have to be completely rewired anyways. Just by looking at it, they're going all over the place here. So that leaves me with 4 wires, which makes sense to the schematic. Because again, we have 3 lamp connections, and then we're going to have one common between all 3 of them, right? So we need to just locate which wire is which for all of that right now. There's a very easy way of doing this. It gets a little tricky with a meter like this because this is such a high impedance meter, but I'll show you how to do that. Now, this one lead here that was the extra lead, now this one was the one that was capped off with a little bit of heat shrink tubing on the end of it. And this runs over to this tube socket, which looked like it tied to the filament pins, but it doesn't. This one lead right here could completely destroy the sensitivity of this radio receiver just by having it capped off and wrapped around the other leads. Reason being is that this lead ties to pin 3 of the 6A8. I'll zoom on into that. So that's pin 3 of the 6A8 right down there. You can kind of see a little bit of that wire running down the bottom. I got to keep my fingers away from this because there's high voltage in here. So I'm a long ways away from it. It looks close, but I'm a long ways away. Down on the bottom there, you can see that wire that kind of curves around, and then that attaches to the same pin that that lead is attached to. That's the plate lead of the 6A8, which ties to the IF transformer. It ties down to that point right there. Again, I'm about this far away from that. It looks close because of my angle, but I'm a long ways away from it. It ties to that point right there. There's high voltage on that point. So just by having this one lead here capped off and wrapped around other wires could completely destroy the sensitivity of this radio receiver. So I have the meter here set to 300 volts DC. So that's the second scale down right there. Okay, so this would be 200 volts and that would be 100 volts. Let's see if I can get all of this in the shot here. Okay, and I'll get the focus on the meter. All right, this is zeroed out. It's just that this is sitting like this because there's, you can see just me touching it and stray voltage here. So what I'll do is I'll tap this right to where this lead is attached to. Look at that. It's 290 volts on this wire. This is that wire. So what I'll do is I'll zoom on out. Right? Here's that wire. Watch the meter again. There's 290 volts on there. Good thing I checked that. These are like low voltage leads right here. This is all in the filament section, right? There's a B+ lead running right up to the dial lights. That's a disaster waiting to happen. So this wire has to just be clipped right off. And in order to even clip that off and do anything to it, I have to shut the entire radio down because I can't get clippers in there. There's high voltage all over that. So what I'm going to do is I will do that right now, get this one out of the way, which of course will help the radio's performance big time. Get that out of there, and then we'll search for which leads are which for the dial lights. I removed the wire off the plate of the 6A8 tube, so I can get that out of the way. And now what I need to do is locate which wire is associated to what portion of the band switch here. Now, I know that the center tap of the transformer ties to the chassis. So no matter what side of the transformer is tied to the switch, I should be able to get a switched reading by attaching the common lead of my AC meter to the chassis and then just searching each one of the wires. So I'll give you an example here. Now, using a vacuum tube voltmeter for doing this can get kind of tricky because it's so sensitive that if I just touch the tip with my finger, you can see it just goes right off the end. So I'll know I have a lead that's tied to the filament winding when I get a 3 volt reading here, because again, I'm at the center tap. So let's go to this far end here, the extreme counterclockwise position, and let's look for 3 volts. So we'll touch this one here first. You can see that's off the end, so I know that this wire is open. This is an open connection right now to that switch, so this isn't selected. Let's go to the second one here, which is beige. Oh, and there's 3 volts there. So this is attached to the filament winding. Okay. So you know that the brown is open and the beige is attached. So if I take a light bulb, I can show you that. So beige is attached. There you go. See it lighting up? Now if I take the brown lead here and touch it, I get nothing, because it's an open connection. So we know that beige is the extreme counterclockwise position. So what I'll do is I'll just put a hook in that one, because I know that I've found that lead now. So I'll move that out of the way. So I'm left with 3 other wires. So we'll go to the second position, which would be band B, because we know that A is on one side and C is on the other, whether they're like this or like this. This could be A, B, and C, or this could be A, B, and C. We really don't know. We'll find that when we get the entire radio working. So again, back to B. So let's try this one here again. Open connection, the black one, open connection, and the red one is 3 volts. So we know that the red one is going to be B, or the center position. So if I take a light bulb and touch it here, we get light. Okay, so I'll put a hook in that one. Move that off to the side. And then, on the end, we should technically get a reading on each wire that's the same, because one is going to be the switch and the other one would be the other end of the transformer, right? If one of these is common. So here we go. Surprise, surprise, 3 volts. And this should be the same. 3 volts. There we go. Now, if one of these wires is attached to one end of the transformer and the other wire is attached to the switch, I should get a full 6 volt glow off of one of these light bulbs. So I can put this here, and I don't. So what is that telling me? Well, what that's telling me right now is that both of these leads are attached to the same point. So this is really starting to unravel like a story here. This lead was attached to pin 3 of this tube over here, which is the plate. If we go 1 pin over, that's the filament pin. So chances are that filament pin is common to all of these leads. But what's happened is somebody attached this lead 1 pin over to the plate lead, and then it got capped off. So the schematic only shows 3 bulbs, as we saw earlier, but we have 4 wires. So what is that telling us? Chances are the reason that this has 4 hooks is maybe this version did actually have 4 sockets, and maybe one of them is missing or one of them broke. So somebody tried to replace it with just a generic socket like this one here, and it didn't work because it's, referenced to the chassis. Whereas these ones, both the leads are isolated. Nothing is referenced to the chassis at all. So this is isolated, and the center conductor is isolated, and this that attaches to the chassis here, the clip is isolated. Whereas on this socket here, the clip is actually attached to one connection, so it shorts out the filament supply. So there's a really good chance that this did actually have 4 bulbs, even though the schematic only shows 3. Again, the hint is that this has 4 clips for 4 bulbs. So 2 would be on the broadcast band because that's the only 2 areas that is the entire half dial. So the broadcast band takes up an entire half of the dial glass. Whereas the other 2 on the top, there's 2 bands contained within 1/2 of the dial glass. So in order to test this out, what I can do is get my probe here and very carefully attach it to the filament section here. So now we know that these 2 here should be connected to the same. So what I'll do is I'll just clip this to here. Hopefully this will fit in the clip. Yeah, it's going to probably want to pop out, but so we should get a full 6-volt glow then. Look at that, full 6-volt glow, and with this lead, full 6-volt glow. So that tells us that these 2 leads are attached to the same area on the switch. And then if I move this, now you'll see that the red one is attached to the center, right? So we shouldn't get a glow. So what I'll do is I'll move this back to the center, and now it should glow. Oops. Is that the center? It is the center. Here we go. There it is. There's the glow. And then if I move this back to the far end, the counterclockwise, it shouldn't glow with the red. No glow. But it should glow with the beige lead. We just successfully figured out the wiring for the dial lights. That easy. So now what I need to do is I need to find another one of these sockets. Hopefully I've got one of these in my stash of stuff, something that'll work that I can put on here so I can get 2 lights on the broadcast band. That'd be kind of nice. Maybe that was an addendum or something that they did later on, or maybe in an earlier schematic they actually used 4 instead of 3. I really don't know. So this lead that I've cut off will get reattached 1 pin over to pin number 2, which would be the common to all of these lights. And then these are all switched. So technically, if I was going to mark these, I'll just shut the radio off now. So if I was going to mark these, what I would do is I would twist the brown and the black together because they are the same. Right? Doesn't matter which one goes to which light on the broadcast band. So we have 2 of them here. And then this would go to the center. And this one would go to the other extreme end, the counterclockwise position. Again, I don't know whether this is band C or band A, and I don't know whether this is band C or band A, but I do know that the red is band B. So I'm going to mark this on the schematic so that I know this here, and I am going to fix the dial lights right now, and then we'll look for why the radio is sitting silent. So there's obviously more issues. I've reinstalled the lamp sockets onto the dial face, and I've also made another lamp socket out of another bayonet connector, and I'll show you that here in just a little bit. And that worked out very well. I only have the common lead attached to all the sockets, and I only have B attached. So I haven't attached A or C because there's been so many wiring errors in this. If A and C are backwards, it would be horrible to cut these wires short. They look so nice, and then find out, oh, they have to go to different spots, and then I don't have enough wire left. So I just want to play it safe. Another thing that really raises speculation is in the band switch position, in the far extreme clockwise position, according to these 2 wires that have voltage on them right now, that would be A, or the broadcast band, because these 2 here would be the only 2 areas that could light the 2 lights for the broadcast, right? So this would be A, and it goes backwards then. So it goes A, B, and C. Normally it would go A, B, and C, right? So that is kind of strange, and until I can listen to this thing and make sure that, you know, the far clockwise position is the broadcast band, I don't want to go cutting these wires short. That's the only reason that I've left A and C unhooked to this point still. Again, we'll determine that here in just a little bit. And I've marked the switch positions that I found already on this piece of paper. So beige, red, and then brown and black is the way it's wired right now as you go clockwise. So that's where everything is. Now the thing isn't receiving, so we have more problems here. You know, no matter where I move anything, it just sits quiet. Oddly enough, I hear an odd crackle out of the speaker every now and then, so that is a good sign. So we obviously know that we have B+. We looked at it there earlier, so grab the meter here and we'll take a look at some of the B+ lines. And we have just under 400 volts there, just under 390 actually at this point right here. And over here we have just under 300 volts. So this would go through the field coil and come back out to this capacitor. That's the reason that we have that drop there. And of course the rest of the radio is loading that portion. That's the reason we have this. So there's current being, you know, a lot of current being drawn through that field coil right now in order to magnetize it. So we do have B+. That is a good sign. And when we looked at the mixer plate, we know that the mixer plate has B+, so there's a good chance that the oscillator is working in this thing, but, you know, again, it's silent. So the only way to tell is either to grab an oscilloscope and go probing around, or get the Carlson Super Probe and make things really simple. So that's what I'm going to do. I'm just going to go grab that probe, I'll set it up here, and I'll just go listening around in the receiver. Who knows, maybe the thing is actually working and this just something simple. So we'll find out here in just a moment. All right, let's take a look around inside the radio and see if we can find any signals. So what I'll do is I'll turn on the Super Probe, give it a little bit of audio. Right now it's in detection mode, so it's sitting silent, which is kind of nice. Now when I get this close to an RF source, you're going to hear kind of a rushing noise, and you'll see this green LED come on and light up. And that'll tell us if the oscillator is working without even needing an oscilloscope. So in order to verify whether the oscillator is working, I just need to go close to the mixer tube. As you can see, the oscillator is on. You see that? Quite a ways away from it even, and you can see that it's... So no problems there whatsoever. So I know the oscillator's on, and I can go up here, and I can determine which coil is actually doing the oscillating. So I know that this one is not doing any type of oscillating. This one is not doing any type of oscillating. And this one here, as you can see, is. So this is the oscillator coil right here. As you can see, nothing is happening in here or in here. But here it is. So, of course, going close to the actual mixer tube, we're going to get pretty high strength right there. Now, the next thing I want to do is I want to go close to the IF chain, and I want to see if there's actually anything that's going to be heard within this radio receiver. So I can just do that by sweeping close to the IF section. So now what I need to do is click the switch so that it'll detect that properly.
A social group, the guy is willing to automate the process.
So you can see that.
The illusion of actual engagement.
So that's right at the detector tube.
Having an app or a program, just click like to every post of yours that I see.
So the thing is receiving. It's just not making any sound. So right there, that tells us that we have a problem in the audio section. Just that easy. No oscilloscope needed, no anything like that, and we can use our voltmeter to try and find the issues from this point on. So at any rate, that's the Carlson Super Probe, just made that a whole lot easier. If you're interested in building one of these things, all the plans, the circuit board diagrams, schematics, layout, alignment procedure, everything is available on Patreon. This is one of my little inventions that I've released. Whenever I design or invent small things like this, I release it to my Patreon community, and many, many people have built this actual version right here and are extremely happy with it. There's a lot of other inventions up there as well. Many of them you've seen on my channel if you've been here for a long period of time, and there's more coming. There's a lot more of these types of things coming. At any rate, this is there if you're interested, and the link for this will, or the link for Patreon will be below the comment section there. It'll be pinned actually at the top of the comment section below the video's description. So anyways, back to this thing. So what I want to do is now I want to find out why there is no audio. Now, the audio system or audio section in this really isn't all that incredibly difficult to troubleshoot. It's really these stages. We have audio at this point right at the detector tube. So what's left? This and this. Now I heard crackling out of the speaker earlier. So that's a really good sign that at least there is some life in the speaker, right? So we know that we have B+ on the other side of the field coil. So it's going through the field coil and we get drops. So we know that the speaker, without even testing it really at this point, is magnetized. So all I need to do is start looking for voltages in this section. And the first thing I want to do is locate the plate of the 6F5. Now the plate on the 6F5 is pin number 4. And I want to test that, and I also want to test the surrounding voltages as well. The 6F5 is simply just a triode over here, and then we have our output tube here, which drives the audio transformer. So we'll start here and move for there. Maybe there's signals missing going into that tube, or, you know, maybe there's just B+ missing. Who knows at this point, right? So let's find out. So this is the 6F5, and I need to locate pin number 4 of the 6F5, and I do have a light over here that I can grab. Did have my flashlight. I don't know what happened to it. Probably mixed up in a pile of rubble there. I'm just using this as a flashlight. So that's pin 4 right there. So I want to see if there's any plate voltage on pin 4. It should actually be pretty high. There's nothing there. Well, that'd be a good indication of why it's not amplifying. See how quickly this goes? So there's no plate voltage there. So if I look under here, there's a wire running off to this resistor. Wire runs off to another tab to this resistor right here. So this is the other end of the resistor. Oh, what was that? There's a bad connection there. This is going very quick. So you can see there's nothing here, but when I touch here, there is. And when I push on it, it came to life. And there it is.
How can we get people to behave in a manner?
You know what? It actually looks like the wire is broken at that point. And when I'm putting the probe on it, it's joining it. I'm not going to touch this. What I'm going to go do is get a different lens, and I'm going to zoom right on into that so we can actually see what's happened there. I'll be right back. All right, let's zoom on into this point here and see what's going on. So here we go. Well, that sure makes it a lot easier to see. Look at that break right there. See that little break right there. That almost looks like, well, it could be just a break from maybe mechanical fatigue, but it almost looks like it's been pinched, like maybe it's been accidentally clipped at one time. And maybe it, for a long period of time, who knows, maybe it's just been making contact. Because look at the wire is extremely dirty, so it doesn't look like it's been worked on. It doesn't look like it's been soldered or anything. This looks pretty original at this point. So who knows? Maybe it came from the factory like that, and it was just, you know, the tension was keeping the connections together like this, or, you know, something like that. Who really knows? That's very interesting. So when I join that,
Right? It's what gives rise to the field of artificial intelligence.
you can tell the capacitor here is storing a bit of a charge on this side, and that's what's allowing it to decay like that. So very interesting. So maybe we found an intermittent issue that's been there since the beginning. Who really knows? So what I'll do is I will add a little bit of solder to this right here, and then we'll take a look at the dial lights, and then take a quick listen to the band. Now, this sounds like this is the broadcast band right now. So, see if I move the... Yeah, it's definitely the broadcast band, and it is in the far position. So I moved that around. You didn't see that, but I moved the dial around a little bit here. So I'll just zoom on out on this here. So if I move this out of the way and grab one of the dial lights, which is behind here. So there should be, if this is the broadcast band, this should light up. And sure enough, it does. See that? So I can wire these to the broadcast band, so obviously the other one is going to be C then, so that's kind of nice. These at least are right. So what I'll do is I'll put some solder on that. I'll reconnect all the dial lamps now because I know where everything goes, and we'll take a quick listen and see how this little radio performs. Now, this is no alignment or anything. This is just the way it is. So the fact that it's coming to life like this is actually kind of impressive. I removed the previous 2 separated wires from these 2 resistors here and soldered in one solid wire, and I refastened the capacitor over here as well. There was enough lead left over when I removed this from the previous J-hook method that I could unwrap the wire and then just run it directly over to the resistor. So that does clean things up a little bit there. Now technically this entire receiver is full of that kind of a J-hook method. So what I'll do is I'll just move the camera over here just a little bit. And you can see that here with these capacitors. You can see that the leads have been cut to the capacitors. And what they've done is they've just tied into the existing leads. You see that, this little Y right here. So that does look pretty messy. So technically the entire receiver could be cleaned up at this point, but it's functional and it works, and that is a lot of work just to clean that up on the underside of the chassis, right? So if I was to go in here and start on this project, none of this would be like this. It would all be like this connection that we just looked at up here. All right, let's take a look at the dial lights. So I'll turn this on. That's the broadcast band on the bottom. That'll be nice and evenly lit. Band B, and band C. Now they have this really interesting little light shield that fits over the lamps, and it's a metal light shield, so I don't want to put this on while the bulb is on. I'll probably put some more of that high heat fiber tubing underneath these things to make these tight. And that shields the light so it doesn't shine all over the place, and it keeps it more into the actual little band area. So you can see the red lights up, and then the green would light up here. Now, here's another thing that adds to the mystery of this story here. This is one of the light shields here that was made. Why has it been so butchered up at the end? See what I mean? This is the entire thing. So I think what's probably happened here is these are all factory light shields, so there was 4 of them in here because we can obviously see that each one of them has paint on it like this and like that. So I think what had happened is the person that was working on this and that had replaced this original bayonet light socket here, I'll talk about that in just a moment, that had replaced it, found that this was actually shorting. So he tried to cut some of the shield away so that it wouldn't short, figuring that this thing was creating the short when it was actually just shorted directly to the chassis through this little hook here. So you can see as you go along, you can kind of put a story together of what the previous person was thinking when they were working on this. Now, this new one that I've installed is isolated from the chassis, so the barrel itself is a separate connection, and then the center conductor for the bulb is a separate connection again. So this is isolated, whereas the other one, I don't think I have that other socket here, it's probably pushed to the back of the shelf or something. At any rate, the other socket itself, the barrel was contacted to the chassis. So this is isolated in this situation. So this way we get that effect right there. So everything is working fine. There's no shorts. Now this was originally just a long straight piece. And what I did is I measured this up and put this here and then bent this over and made a hook and then pinched it together. So it's a crimp fit onto the original fitting, and that worked out very well. So that's nice and tight on there, and that will stay there. And then this is the one that went on that bulb. So this would end up sliding back. This actually tensions onto the glass portion of the bulb, which is interesting in this situation. So what I'm going to do is I'm going to put that high heat tubing over this, that stuff that I've talked about in many of my other videos, that fibrous tubing over each one of these, just as a little bit of extra protection so nothing does end up shorting out, so it doesn't slide back and touch the metal clip or anything like that. and that gets that all together. Now, underneath the dial glass is a little bit of residue, not a whole lot of residue. And as you can see, some of the numbers aren't completely solid anymore. Now, here's the thing. What happens with a lot of this older paint is it almost turns to a powder and then it falls off. Now, if I was to remove this glass, so I remove the needle, push this little clip up and slid the glass out, chances are I would lose half the dial. It would just come off. So even though there's a little bit of dirt underneath the glass, to preserve this dial face, it's absolutely crucial that I do not go under that glass. Some of the paint is solid, some of the colors were solid, and some of them turned to like a powder, and you can see this here where it's come off just a little bit. So I want to leave this alone. What I may do is take a red marker and remark the red filter on this side, and I may remark the green filter on this side, and that might make the green and the red stand out just a little bit more. As we saw, I'll just put this one over top here like so. As we saw, when we go over to this one here, you can see the red filter works pretty good. It lights up the red, and the green isn't so lit. Whereas if we go over to the green, we can see the green trying to light up. And then, of course, when we put the shield on and everything else, that'll greatly help with that. So I'll do that first, and we'll take a quick listen to the radio receiver. Let's take a quick listen to the broadcast band, see how well it performs without an alignment. Lots of stations in there. Pretty sensitive too.
Production and Joe isn't going on shows.
So you can see there is a ton of stations on that band. I'll just turn this off because it's noisy. So it's not working too bad without any type of alignment, which is a really nice sign. Now, of course, we've done all the troubleshooting in this video, and this video is getting pretty long at this point. But if you're interested in actually seeing a complete alignment on this, you can let me know in the comments below. And, well, in a moment here, we'll check out the other bands as well. I'll just see if the other bands are working. And of course, you know, that would be a complete alignment, and that is a little bit time consuming as well. But again, if you're interested in seeing this go through an entire RF, IF alignment and an oscillator alignment, you can let me know below. Let's take a listen to the shortwave bands real quick here and see how well they perform. Wow. That's the time signal. Time signal again. So it's not working too bad. Try the upper band. Shortwave station in there from some part of the world. This big carrier there. Station there. More there. Nice thing about this dial is it has a fine tune option. And then when you come to the stop, it gives you a coarse tune. So you can pass a station and then go back and fine tune into it. It's kind of neat. Another radio station there. Another one there. So lots of stations. This one here. Lots of stations on the band, so it's not performing too bad for no alignment, but again, you know, that can always be improved. I'm sure this thing is most likely way off, noting what has already been done to this thing and everything like that. So not too bad. These capacitors here are just looky-loo capacitors, a little bit loose. Not doing anything, they're just on the top side of the chassis for looks. So all in all, it could use a good cleaning and an alignment. Other than that, not bad for the 1930s. It's alive again. If you're enjoying these videos, you can let me know by giving me a big thumbs up and hang around. There'll be many more videos like this coming in the near future. We'll be taking a look at vacuum tube and solid state electronic devices alike. So there'll be a lot of restorations coming as well. So if you haven't subscribed, now would be a good time to do that as well. And if you want to be notified as soon as I post a new video, don't forget to tap the bell symbol. If you're interested in taking your electronics knowledge to the next level and learning electronics in a very different and effective way and gaining access to many of my personal inventions and designs, and there's also another 90 videos there as well, you're definitely going to want to check out my ongoing electronics course on Patreon. I'll put the link just below the video's description under the Show More tab, and I'll also pin the link at the top of the comments section. So click on the link and it'll take you right there. All right, until next time. Take care. Bye for now.